So for this first case we're going to look at, we're given the slope and the point. And basically all we need to do is we need to create a line that has the same slope as the one described, and it passes through this point of 3, 5. So let's just say like 3, 5 is like here. Well, in that case, we need to have, and our slope is going to look something like this. Now basically what we need to do is find the equation that allows it to pass through that point. In order to do that, we need to use this equation, y equals mx plus b. Now, what do each of these stand for? Well, that's where the x and the y are the x and the y coordinates. The m represents the slope, and b represents the y-intercept. I'll just put int for short. Now, basically, what the y-intercept, another way to think about it is that the number is going to be when this line passes through this x-axis right here, this vertical line. And so whatever this number usually is, it's usually what b is, or the y-intercept. But usually when we have something like this, what we're going to do is we're going to solve for b, because we're already given the slope and we're already given the x and the y. So when we put that together, the 5 goes in the y, so that gives you 5 equals, and then the m is going to be 2, and then the x is going to be 3 plus b. So then we just kind of use order of operations, where 2 times 3 is 6 plus b, and then we need to subtract 6 on both sides, and that gives you b equals -1. So then we put that together, we rewrite the equation, we already put back the 2 and the m, so we go 2x minus 1. And then there you go, that's your equation. So to kind of give this a visual example, I'm going to be using a graphing calculator website called Desmos, totally free, and I absolutely recommend. So we have this point that we had 3, 5, because it is 3 in the x and 5 in the y. And if we just have a regular line that has the slope that was given, which was 2, and let's say we have it start at the origin, this is what it would look like. So in this case, I can adjust my y-intercept. And so when I adjust my y-intercept, the line looks like it's going from left to right or up and down. So that's kind of how the y-intercept affects the line, is it sort of defines the position, where the m kind of defines how steep it is. You know, when the higher it is, the steeper it looks, and so on. So we know that the b from that we calculated was, oh, there you go, -1. So that goes through the point, and since, like we said before, the y value is b at when it passes this vertical line. So if we look at that line is 0, -1, -1 being the b. And so, that's kind of how it all works. So another way we're going to look at this is we're going to use what they call point slope form. And so point slope form basically means that instead of solving for the y-intercept b, we're going to be having 2 intercepts, a y-intercept and an x-intercept, as shown right here, where the y-intercept is k and the x-intercept is h. Another way you can rewrite this is basically just by moving the k around, so it has something like this. So the way it kind of works is that instead of, because normally when you make a line, you kind of start at the origin, at least for when you're using the same form we used last time in case 1. Instead of starting from the origin, we're going to be kind of starting at this point. It's going to kind of act as our origin. And so with that, how that works is, so if we plug in the 2 and the m, in the 3 and the 5, well, in this case, instead of the x and y, this is going to be our h, and this is going to be our k. So when we plug that in, you get y equals 2 x minus 3 plus 5. And now all you pretty much have to do from there is just algebra, so order of operations. So yeah, I got to distribute, so you get y equals 2x minus 6 plus 5, and then that gives you y equals 2x minus 1. So this is pretty much going to give you the same thing you got from the last problem, but it's just a new way of doing it. So as we saw from part 1, we know that the m, or the slope, is kind of the steepness of this line. But how do we visually represent that? Well, slope has always been defined as rise over run. And basically what that means is the rise is how far up and down you go, and the run is how left and right you go. So the slope basically stands for every unit that you go up or down, you go to the left that many times. So what we're going to do with those points is we're going to use them to prove how the slope is 2, because I already know the slope is 2, but I'm going to show you how. So yeah, as I said before, the slope is equal to the rise over run, and the rise is just the change of y, essentially. And so it could go either one of these ways. Your teachers normally recommend that you use this method, mainly because if you're kind of judging it from left to right, the point that's most on the right will be x2 and y2. But you can honestly do either way. It's just this way is easier, because if you do it this way, oh, that's not what I wanted. If you do it the one on the right, you're just going to cancel out negatives. So anywho, if we plug that in, you get, so let's see, we got -1 minus -3 over 1 minus 0. And that, it's going to be that, okay, and then that's 2 over 1, which is pretty much going to equal 2. So from our calculations, yeah, we pretty much saw that for every unit it goes to the right, it goes up 2 units. And so another way, if we want to see, well, how do I know how far up it goes when it hits 3 units? Well, this is how we can kind of visualize that. So 1, 2, 3. And then it rests on this point right here at 3, 3. So this case is pretty similar to the first problem we looked at, but instead of just being given the slope, we're given the entire equation of the line. And in this case, the equation of the line is just 2x plus 2. And then the point is at the coordinate 5, 4. So we're given the equation of a line and the coordinates of a point. And so in this case, what we're trying to do is we're trying to find the equation of a line that is parallel to this one, but passes through this point. So that brings up the question, what does parallel mean? Well, parallel, in terms of graphs and such, all it means is that they have the exact same slope. Just kind of like how we did in the first one. So in this case, what we're trying to do is we just need the 2, because that's the slope, right? So all we have to do is since this is our M, and then this is our H, this is our K, we just plug that in. And then you just, you distribute. And there you go. And let's see if that matches with the graph over here. Well, it looks like the lines are parallel. And once again, you know, like parallel just means that no matter how far you zoom out and how far up it goes, these lines will never cross. They will not touch each other. They won't even get close. The amount of distance between them stays the same forever. So if we're looking at perpendicular line, well, what does perpendicular mean? Well, perpendicular just means that when it crosses through, say, these two lines, but when it passes through this black line, the angle between them is going to be 90 degrees. And so I'm just going to keep that in there. So yeah, they just have the perfect 90-degree angles. So how do you find that? Well, perpendicular angles can be found by taking the negative inverse. So let's see, I'm going to write this as so. To find the perpendicular angle, we just plug in this slope that we got already. And you don't have to write that subscript, that's just something I'm doing. It's -1 over, then we plug in 2. And so your new slope is going to be -1/2. So now we can pretty much treat this like we did in the first problem or in this one, but so we're given, this is going to be our new slope. So this is our slope, and we're still going to use the same points. So now we plug that in. Yeah, x minus 5 plus 4. And then you just kind of distribute and all that. So that's plus, because there's the two negatives. Yeah. Another way you could also write this if you needed to simplify is you can kind of take out the 1/2. So, or you can also write it like this. These are the same thing. It's just different ways of writing it. So, if we look at the equation of this line, so I'm going to simplify it with the -1/2 x minus, or no, plus 13 over 2. And so now we have this perpendicular line that is perpendicular to this black line and this blue line, but it's mainly the black line we're focusing on, and it passes through that point. Because, I don't know if I mentioned that before, that was kind of the entire point, is that we make an equation of a line that's perpendicular to the one we were given, but also passes through that point. So it's pretty similar to the one we just did.